All right, so today we are going to start a new topic in linked lists or lists, I should say, and that is about queues. And since we have enough knowledge of lists as well as stacks, I think this should not turn out to be difficult to understand. But we'll briefly look at one of the uh, basics related to the queues. Then we'll look at a specific application of queues. Um, Related to call center when clients make a call and there are a fixed number of people to attend to the calls, right? So that naturally can be embedded, can be implemented using queues. So that's what we'll look at. Finally, we'll look at one specific implementation aspect which comes into picture when you are implementing queues using arrays. While most of our discussion will be related to ADT queue, but that implementation aspect will come into picture, and that's a little small subtlety is there, which I'll explain. And that will be the end of not only queues, but also list related structure. So let's hope we are able to do that today. Let's see. Okay. So again, like a stack, queue is a special list, and that means that there are restrictions on what kind of operations we can perform and where all these operations can be performed. For example, in case of stack, we had insertions and deletions at one end. In this case, queue, the insertions are going to be at one end, that is at the end of the queue, whereas the deletions are always going to be at the front of the queue. And that usually can be nicely modeled using head as well as tail of the list. So the insertions are happening at the tail and the deletions are happening from the head. And therefore this is also called as, since the first element that goes in is also the first one to get removed, therefore this is also called as a FIFO, or the first in first out. Contrast it with last in first out in case of stack, right? So what is FCFS in this context? This is what might be seen by or might be read by some of you in the context of queues. So that is first come first served, right? So as Aniruddha and Rishabh and Vishnu Prasad have said, this is first comes first served. So that is what is our queue data structure, right? So when we are thinking in terms of a queue where there is a line, a queue of people, so whenever you join the queue, well, ideally you should be joining at the end of the queue, and ideally it should be the first person who should get served first, right? So that is first come first served order, also called as a first in first out order. All right. So in general, we cannot access arbitrary elements. That is similar to the stack. Depending upon how you want to implement ADT and what kind of applications you want to support, you can have access to arbitrary element or not. But typically, it is not there. Otherwise, you are better off with using a list. The insertion into the queue is sometimes called as push and many times called as NQ, and the removal from the queue is sometimes called as pop and many times called as a DQ operation. And I have shown one of the ways in which a linked list based queue can be implemented. And as you can see, it seems to be a doubly linked list. Why is that? Why should it be a doubly linked list? Why not a singly linked list? Correct. But can't we, Aniruddha is saying push and pop are at different ends. That is correct. But can't we still do the operations using a single queue, single list or singly linked list? Okay, so that doesn't seem feasible with a singly linked list, if because the pointers are only in one direction. So if you assume that the next is the only one that is available, then from head you will be able to go to the next, which means that the removal you will be able to do. Right? So I can remove 4 and then head will start pointing to 2. That is okay. But when I have only the tail pointer, when I have only the next pointer from tail, uh, I can add another, let's say the new node, which is getting inserted at the end of 5, and then that adds the next to, sorry, we are talking about the next, right? So 5 dot next becomes whatever is the newly inserted, and I can have a pointer pointing to the last element, the newly added element, right? So that becomes possible that I can add at the end of the list, and I can remove elements from the start of the list, right? So it is possible to implement it using a singly linked list. It's not, at least I don't see any problem. It's just that typical implementations will require, will use doubly linked list, but that doesn't seem to be really required, right? Unless I'm missing something. Is my explanation correct? Is there any problem with that? That you can implement a queue using a singly linked list, where insertions are happening at the tail, you maintain the next pointer, and the removals are happening at the head. Okay. All right. So I hope you guys are agreeing with me. Okay. Thanks, Vishnu Prasad. All right. So that seems reasonable. Okay. So let's look at the specific. I mean, we have been talking about the ADT, right? So whenever we are talking about a particular data structure, not necessarily data structure, it's also about whenever we are talking about an interface of a new entity, like when we are talking about an object type, we should talk about the ADT, right? So your classwork is write down the queue ADT. So if you have a queue, what all operations should it support? What all interface it should make public, right? So please try it out in your copies or online. And if someone wants to share, feel free. Okay, so I hope your interface looks something similar to C-based structured queue or C++ based class queue. Both of those are shown here, although I have used different set of elements, but you can use either of them. Right, so I definitely support a push operation or an NQ operation of a particular element, and it returns nothing. Element is returned by pop, right? Or you can have top and followed by pop. Either way is okay. And I do support is empty. If it's an array-based implementation without dynamic array allocation, then we should also support is full. In addition, you might want to support front and back. That is essentially the top, similar to the top in case of stack. And we need to peek into the queue to figure out what element it is without popping. Okay, so those are typical operations in the queue ADT. And as we get into implementation, we might as well want to support a constructor for the queue, which might initialize the head and tail to null, or head and tail to, let's say, zeros in the context of array-based data structures. Right? Any questions so far? Anish is saying, why do we need element back? That's like a stack. Yes, that is correct. That is very similar to the stack's pop operation, top operation. It's not necessary that that is required in all applications. Many times you don't, but sometimes you might want to. So for example, you might want to decide based on the first value that is going to get removed or the last value that was just inserted, what you should be doing now, right? So in such cases, you might want to support whatever is the current element at the end or at the entry of the queue, but otherwise in many cases it's not really required. In fact, I should mention, since you have said that it's like a stack, you can implement a queue by you can implement a stack by using a queue and maybe back operation, um and something more, right? So that I'll give you as an exercise, but please think about it, that how will you implement or simulate a stack if I just give you a queue ADT, right? And your back operation might turn out to be useful there. All right, Salman is asking, is front at the head or the tail? The front is always at the head, right? So we are, I mean, in general, whatever queue we talk about, where there is a list of people, and the person who enters the head of the list should be the one that first get removed or served, and then the last person to enter the queue should be the tail, where the next person is going to join. Vishnu is asking, what function we use depends on what type of linked list, single or double, we use in implementation. That is correct. Very good. Very correct. So the front will make sense when you have singly linked list implementation. The back will make sense. Well, back can still happen even if you have a singly linked list based implementation. Yeah. So in this case, it seems to be okay that you can use both of these front and back in the context of singly as well as doubly linked list. But yes, in general, the API that you support can be dependent on the implementation, and that can also change the complexity of this. But that also gives you a little bit of contradiction with respect to what the ADT should be supporting, right? Typically, the ADT should be independent of the underlying implementation, but there might be some small set of functions which, because of the certain implementation, you are able to provide, right? So those will be more like an add-ons which help the outside world to implement or use your data structure more effectively or with lesser complexity. So that is possible, but by and large, the ADT should be independent of the underlying data structure. Yeah, good point, Vishnu. In STL, is it singly or doubly implemented? The queue is implemented, I think it's implemented as a doubly linked list, if I'm not wrong. The reason being that it's a specialization of the list, and the list by default is doubly linked list. Mayank is saying back cannot be supported with single linked list. I think that is possible, right? So if you have a singly linked list and you have a tail pointer, right? So head, next, and then tail, the back can be supported with that, right? Because you are only inserting at the back. So you never have to go from n to n minus 1. Right? So it should be supported. Yeah, Murari is supported. We can if we keep extra pointer. Yes. So we are assuming, like I mentioned probably on the last slide, you can have a tail pointer, and that will help you in the implementation of back also. Any other concerns? Yeah. Good. So I'm able to see that you guys have started thinking from the implementation perspective also, and that's very good. That does show that you are now comfortable with lists, especially after the assignment and the quiz. Good. So like we had looked at small code in C++ which used STL stack. So we just pushed the elements 0 to 9 and popped the elements and printed, right? And that printed 9 to 0. In a similar manner, we'll use the STL queue, right? So that is the ADT that is being supported. So let me just do that. And that means I'll have to stop presenting and then reshare the screen for the code. Okay, so it's coming up. Right. So this code is essentially very similar to what we had for the stack, just to illustrate how to use an STL queue. And we define a queue of some type. We push the elements into the queue, and by default, those are going to get pushed in the order in which they are inserted. And while queue is not empty, I am going to, again, similar to top and pop in case of stack, we are going to use front and pop in case of a queue, and that will make sure that it gets printed in the order that those were added. Just to confirm that, it prints it in 0 to 9 order, right? So that is what we were expecting. Okay, so that sounds good. There is a question, Mike, in queue, does node have previous pointer? Yes, if you have a doubly linked list implementation, then you will have a previous pointer. Otherwise, you don't need it really. I mean, you can implement a queue using a singly linked list. In the case of STLQ, I think it implements it using a doubly linked list. So you will have some sort of previous pointer also. That can also be understood by thinking about that most of these aggregates, they support this begin to end functions, right? So you start from begin, the start of the collection, then you go over and until you reach the end, which is one past the last element. But more importantly, they also support R begin and R end, which means that you can do a reverse begin, that is starting from the last element and then come to the beginning, right? So that is R begin to R end are also supported, and that does require us to have a doubly linked list implementation. So I think that should confirm that it's a doubly linked list implementation. Good. Any other concerns? Anish is asking, all the functions in the ADT would have to be in the public. Yes, as far as abstract data type is concerned, the ADT part that we are talking about, that must be public. That can also be protected in some way, but let's ignore that for now. So the ADT part is the public interface, which is what is exposed to the world. Right? So the world is concerned only about that part. Of course, we have to, when we come to implementation, we have to add the private functions as well as variables. But yes, in the abstract data type, it is only the abstraction which is going to the outside world, and therefore it has to be public. Good. Any other concerns? Alrighty. So let me come back to the presentation. Unfortunately, when I share the whole screen, the size of the file is increasing too much, and therefore I am just juggling around for individual screens. Okay, so let's talk briefly about applications of queues. Although I mean all of us know applications of queues. So ticket counters, shops where there is a lot of queue, and we call it a queue, right? And then canteens or banks where you have some sort of a token system, right? So you enter the bank, you collect the token, and then if you actually look at the tokens, those tokens have a sequence number, and that sequence number is essentially the position in the queue. And then whenever a particular counter becomes free, let's say in our SBI also, a particular counter becomes free, and your token number is displayed, then you go to that particular counter and so on. And that happens in the token order typically, except that sometimes there are specialized counters for certain processing. In that case, you might see that a certain next token might get printed because that facility is available there, whereas your facility is available only somewhere else. Okay, but by and large, this is a queue, right? I mean, many of you, not many of you, maybe rare of you might have gone to IRCTC counters to book tickets, railway tickets sometimes. So there also we see a queue. In some sense, when we are talking about even Tatkal booking online, right? So that also has some sort of a queue implementation. People who can try, let's say 10 o'clock, you want to try, or 10:30, whatever is the time. At that time, if you are trying, and then there is a queue that is going to get maintained by IRCTC, and only a fixed slots are available. So those who are kind of lucky or can do exactly at that time, those are going to be entering the fixed size queue. Maybe they have array-based implementation, you never know. And those who are in the arrays are going to be the ones which are going to get processed and so on. Resource sharing in hardware. right? In our computers, that also happens in a queue manner. Imagine that you print, let's say, 3 PDFs, and you just give a print call to these 3 PDFs, right? And automatically the pages get printed in exactly the same order within a PDF as well as across PDF. Right? So there is a queue of PDFs that is going to get maintained by the software. Similarly, when you are having, in some sense, multi-threaded program where there are parallel processing going on and all of them are trying to write to a common memory location, sometimes it is the random order of these threads, sometimes it is also a queue that gets minted inside the hardware. And these processes then write to that common memory location at the same time. Not at the same time, in that particular queue order. Right? In operating system, the process scheduling is another example which might use first come first served order. Not always this happens, but in some limited form this does get used. For example, there are always processes which have higher priority. Right? So there are operating system processes and then there are user processes. Operating system processes will have higher priority. But let's say that there are user processes running, then those can be pushed into the same queue and so on. This is not exactly how it gets implemented. For example, in Linux, follows something called as a completely fair scheduler, or CFS, which is actually a multi-level queue. Right? So the priority of your process will go on increasing as your wait time goes on increasing. So anyway, but in some of the server-based processes, for example, we have a computing cluster inside the campus, right, which is there in the computer center. That follows to some extent FCFS ordering. That if you have multiple different students are entering, pushing jobs are essentially processes, then those are likely to get processed in the first come first served order, right? And so on. I mean, you can imagine lots of other applications of queues. Anybody wants to convey any quick interesting examples of queues that they have encountered? Murari is suggesting reloading ammunitions. Oh man, yes, sure. I know that a lot of news on Taliban is going on. Yeah, sure. Uh, sure, I think that's a valid suggestion. Ammunitions, I mean, you can have a long, let's say, pipe in which you are loading different ammunitions, or you might have a sequence of bullets, and as the machine gun fires, then the bullets get fired according to the order in which they appear. Sure, I think that's a very valid and interesting suggestion. I would have, I mean, considering that I'm an academic, I would have probably used the example of a pencil, right, where you have those different parts having different leads of the pencil, and then you take out the one and put it at the back and so on. So that becomes a circular queue. So I would have probably given that example, but I think Murari is more ambitious. Thanks, Murari, for that example. Anish is saying seat allocation of courses. To the extent I know, considering that Dr. Meghna is involved in this seat process, whatever I know about this, it doesn't happen in the queue order. So there are students on one side, and then there are courses on the other side, and there are preferences in that order. So there is a ranked preference. Okay, I think the rank preference that you are talking about is a queue. I see. But it doesn't happen exactly in that order. The reason being that the courses also have a preference on the student. It could be a CGPA order. Okay, so in that manner, the queue might come into picture when you are talking about that order. Sure, I agree. Yeah, there is some element of queue happening there. Although some of you might be knowing that the CGPA violation can occur. That is, a lower CGPA student might get a course, whereas the higher CGPA student might not get it for some reasons, right? So I think those are there in the seat documents in case somebody is interested. But good point. That's a good example. Mayank Anand is saying batting order, their order of out maybe. Sure. Yeah, whatever is the queue that is decided, the order of the batsman that is decided, let's say, about the recent test that happened with England. So we have an ordering, and we usually follow that order as far as people go out and play, except in some cases where there is a reordering required. Maybe Hardik Pandya is asked to go there and collect some runs or something like that. But yeah, otherwise we usually follow that order. Sure, agree. But the order of getting out, yeah, to some extent, yes, but there are inversions, correct. So yeah, it's not fully FCFS, but sure, I understand the point. Good. So that was a good discussion about various applications. Let's discuss about this particular application of call center. Right? Okay, Murari has a point. Does resource allocation in our PC happen in queue? Because if there are too many priorities, then queue ADT may not be very useful. That is correct. It doesn't always happen in the queue. It's in fact called as a priority queue. The way you have used the priorities and the queue together, it's actually called as a priority queue, where there are different processes having different priorities, and like operating system processes will get higher priority. Even within operating system process, there are multiple levels. Even within user level, there could be multiple levels, and so on. In fact, there is a command in Linux to change the priority of a process. Right? Does anybody know the nice name of such a command? I mean, Linux is that way a very notorious operating system, having very arbitrary names. Okay. Kashi Bhatla says very nice. No. But yeah, I think he got the point, whatever I was saying. What is the nice name of such a command? So as Kashi Bhatla and Aniruddha have suggested, the command is called as actually nice, right? So you can actually type it, and you can change the priority of a process. Right? Okay, good. Andrea had stages of a rocket. That's a stack. That's right. It should be a stack. You're right. Okay. Good. So let's talk about a call center. So this is going to be a slightly larger application than what we have seen so far. So far we had an ADT, and then we were just using that ADT to implement a relatively smaller algorithm. In this case, we have to worry about multiple such objects, right? So balance parenthesis, for example, using stack. That was our small algorithm. In this case also, we'll do this algorithm, but this looks more like an application rather than a single algorithm. And it is going to use multiple data structures, and one of them is going to be a queue. So what happens in a call center? So we have, let's say that you have certain product, and different people are using it, different customers are using it, and they face some issue, and therefore they call in your call center. So now there is a support system in the call center where there are multiple people sitting out there, and they are going to take the call of the customer. Now, how many customers are there? You don't know. How many people you require? You don't know, right? So it happens, it evolves over time, how many really you require, but different times of the day, different times of the year, you require different number of people in the call center. So imagine that you can have at the minimum one person in the call center. At max, you can have a very large number of people in the call center, and similarly about the customers, right? So one to many, anything is possible. If there is a single person who is there in the call center to answer the calls, then it makes sense to answer the calls in the order in which the customers are calling, right? And that also seems reasonable. It also gives a way. For example, you might have encountered this, that when you call a call center, some call centers can also give you approximate waiting time and so on. So that also is possible to be done, whether you have one person in the call center or not. But essentially, if you follow a queue order, then you can give such guarantees, at least approximate guarantees, because you don't know exactly how many minutes a particular customer is going to take. So that is our goal, right? So you have some people in the call center who are going to serve, providing the service, and then there are some customers or clients. They are calling in arbitrary order. You have let's say some number of them, each of them, and then we have to follow a queue order to attend to the calls, right? So this is a kind of simulation that we are going to do. Now we cannot make actually calls from our, I mean, you can, but not from the program that I am going to show. So I'm just going to assume that there are going to be people and they start talking to each other. What I'm also going to assume is that each customer comes up with the number of units of time that customer needs service for. Right? This is again unrealistic, but it suffices for our purpose because our focus is on queues rather than on the actual call center. Right? So each customer is going to come up with that I need 3 units of time, or I need 5 units of time, and so on. Right? And then after 3 units of his or her talking to the call center person, then that particular agent in the call center becomes free, and that customer also goes away, and then that freed call center agent is going to be useful for the next call, right? So that is how the queue is also maintained amongst the people who are there in the call center, right? So there are multiple aspects here, and let me clarify that a little bit. So multiple users call a call center and multiple operators answer the call. Each call takes an unknown amount of time. In our simulation, we'll use a known amount of time. Right? When all the operators are busy, then the user has to wait in a queue, right? So there is a waiting queue. Essentially, you require a queue because you cannot service something immediately. If you can service something immediately, you don't need a queue. Correct? So in this case, if there are enough operators, you don't need to worry about a queue, but that is not typically the case, and therefore the calling users need to wait inside a queue. And when an operator becomes available, which waiting user is answered is decided by what data structure underlying is being used. Ideally, it should be first come first served, and therefore the queue order becomes useful. If the users come up with a priority, for example, when you are going by a flight, right? So you have this economy class, which is all of us, and then there is a priority class, right? Business class or something like that. And they do get a priority, right? And we might be standing in a queue which has 20 people, and we are worried that our flight will get missed, and somebody comes and goes directly to the for the check-in, right? So all of these are different priorities, and those priority queues we are going to study a little later when we look at trees. But for now, we'll assume that everybody is having the equal priority. And as this is probably a non-question now, but yeah, we have to implement it, and it's natural to implement it using the queue ADT. So what are the data structures that are required in this case? I'll just hold on for a few seconds here. I would request everybody to think about what are the data structures that you are going to require in maintaining this information. Right? So I'll just move to the previous slide. So think about this problem. Think about where all you will require a queue or some other information. Maybe you require some sort of collection of users, either at the call center or the customers who are coming, the waiting customers, and in process discussions happening between the call center operator as well as the user, right? So please think about that, how you will implement, and at least at a high level. And in case there are any questions, feel free to ask. Okay, Aniruddha says users wait in the queue. Bit string for which operators are busy. Sure. That's a good point. Um, Yeah, but we also need some sort of a mapping between which user is connected with which operator, so that when the user's time ends or the discussion ends, we would like to free that particular operator. So that is also required. Good. Bit string meaning, okay, Vishnu Prasad is asking what is a bit string. Bit string is just a vector of bits, like, or array of bits. Think about it that it's often called as bit string, uh, but think about it as a bit vector or bit array. It can be implemented using a char, but a bit essentially requires a single binary digit. A char can actually accommodate 8 bits, and therefore you can have more optimized or space efficient implementation of a bit string. So you can have a char. Yeah, bool array is probably the best one. Although internally bool array might also get implemented as a character array, but yeah, it's possible to optimize that away. Sure. You can actually create a library of bit string. So you can have a character array, and then when you want to set a particular bit, you go to a particular character. Let's say I have 64 bits to be represented, and I can accommodate it into 8 bytes or 8 characters. So if I want to set, let's say, 63rd bit, right? So I divide it by 8, so I get 7. So I go to 7th bit, 7th character, and within that I set, let's say, 7th bit, and that is going to give me the 63rd bit. All right. So okay, Mayank is asking queue for upcoming users. Sure. And map for operators, null or free, start time, end time. Sure. Shreya is saying 2 queues, one for operators who are free and one for waiting customers. So this is an important point, right? So what Shreya is suggesting is not only that there should be a queue for the customers, that it makes sense, but if you do not maintain a queue for the operators, what can happen? Can somebody tell me? If you do not maintain an operator for a queue for the operators, what will happen? Right. So Anish is suggesting overburdening of some operators, right? So typically the way you are going to assign operators as a programmer is 0 to n minus 1, right? And then if 0 is the person who is going to be, the person will get allotted, and then let's say 3 people are allotted, right? And then 0 gets free. Instead of assigning 4th person, you will assign 0 again. So people who are at the lower end, if you are going in lower left to right order, they are going to get assigned to the users more often, whereas the ones who are having higher ID, those are going to get assigned fewer number of times, right? So that adds a little imbalance, and therefore this idea is very important, that we should have a queue for the free operators also. Aniruddha suggests map for mapping operators to users. Yes, some sort of a mapping we need to create. That map we have not really looked at. I mean, I showed it in an example, but that, think about map as you are just maintaining some sort of a pairing, right? So this operator versus the user ID. Murari says, I did not understand what kind of priority we need take care for users. So the users are coming in at different times, and therefore the person who comes first need to be given the priority. That is the only priority that we. So priority in this case means lower, let's say, incoming time. Whoever comes first, that person should be given priority. That is the only priority that we are talking about. Salman is asking, one queue is enough. At a time, only a group of operators or a group of users will have to wait. That's another good observation. If the users are waiting, that means the operators are not free, right? And if the operators are waiting, that is, there are some free operators, that means that there is no user who is waiting, right? and therefore we might be able to use the same queue for both of them. That's a good observation. For this to be for this to work in our programming, we have to make sure that the user and the operator are both of the same type. Right? For example, if I'm talking about ID of a person, let it be an integer ID, then you can push that ID into the same queue. If these two types are different, which is likely to become the case, then we will have to get into different kinds of queues. Right? But that's a very good observation by Salman, that only one of the queues will be non-empty at max. Right? Okay, Murari says pair of bool comma int. Sure. So that is to map user whether the person is occupied or operator to be occupied or not, or waiting or not even. Mayank says one queue for operator, maybe stack for waiting customer. It should not be a stack for the waiting customer. It should always be a queue, because we want to give the priority to the first person who came.
Sir, like in doubt, sir, if we use stack in place of queue for the waiting customer, then it may be unfair for those who come first and not giving that much time first. But we
That is
can
correct.
use.
So it will, in
But
fact, it will be the reverse priority.
yes, yes, yes.
Correct. Yeah, Salman's approach is saying that if you have a waiting operator, right? So there are 10 operators, out of which there is one who is waiting. That means there is no other user who is waiting. Otherwise, this operator cannot be free, right? And therefore, we don't need to. These free operators, can be pushed into one queue, right? The other way around is that if every operator is occupied and there are more users here than who can be accommodated, then the users are going into the queue. And if there are users in the waiting queue, that means that there is no operator who is free. Otherwise, again, that pairing is possible. So at a time, only one of the queues will be non-empty at max. So that is what is the observation by Salman. Any other suggestions, concerns? All right. So essentially, I'm just going to show whatever I have programmed this with. So there is going to be a user, which essentially means that there is going to be a new type user. Each user has an ID as well as the amount of time that the person requires from the operator. The operator has an ID, right? And then there are additional things. For example, there is a queue of waiting users. This we have discussed. And I'm also using a list of busy operators, right? How this list is implemented, that is decided by how you want the dynamics to be, right? As Shreya suggested, this better be a queue, otherwise the same person, same operator will get more and more work. And then, okay, I think I'm maintaining that here. Sorry, the busy part I'm just maintaining as a list, which means that, okay, so I'll also mention why we need to be careful about the data structure here. The busy operators are going to get free in the order of the starting time plus call time. Right? So if all the call times are the same, then the starting order is the time in which the busy operators will get free. But if the call times are different, then we have to worry about the starting time as well as the amount of time that the user requires. And depending upon that, if we sort this list or keep it sorted, then it becomes easier for you to remove the busy operators from here. If we do not maintain this information in the sorted order, then the operators might get free from this list in arbitrary order, and then we might have to shift something if you are using array-based implementation, or we might have to search to a particular place and remove a particular operator to be put into the free queue because it is unsorted. Right? So this also is a design point which will come into picture. And then we have this queue of free operators to maintain the proper order. Okay. So let's go to the simulation. So simulation is based on time. In this case, the way we are simulating it is things happen instantly in one time unit, right? So we are going in a lockstep manner, right? One time something happens, the second time something else happens, third time something. It's not a continuous; it's a discretized simulation, right? And that's what we usually do in the context of computer simulation. At each time unit, various actions occur. For example, a new user can arrive. A new user cannot arrive at 1.5 seconds, right? So he or she has to arrive at 1 second or 2 seconds. Free operator might get assigned to a user, that is the pairing that we talked about, and no operator is free, so the user needs to be pushed into the waiting queue, or a busy operator becomes free, so that busy operator needs to be pushed into the free queue. Or it's also possible that nothing happens. Why? Because nobody joined at that time. The busy operators, well, continue to remain busy because they still require time, but their call time reduced by 1 unit. So, as far as actions are concerned, there isn't any visible action except for reduction in the time. So, if a user wants 3 units of time, that reduces to 2. That's it. That's what happens when I mean nothing happens. Um, and we have to put this all of these operations together to perform the simulation, and that is our call center.cpp. We have 4 minutes to go. Okay, any questions before I open the file? Okay, so for simulation, we need the input data, and the data could be randomly generated. But what I have done is that I am reading it from a file. So there is a specific format that this file is going to have. What is that format? It is going to read the number of operators. Right? So if I open right, so you are going to have number of operators specified here. That is, in the call center we have 5 operators, and then these are the users, right? So for init, so let me go to that. Okay, that is just initialization. Yeah, while scene, user, and the time. So each user comes, so there is a user ID associated with the user, and there is a time with which for which that user wants the operator to be busy. So 0th user wants 5 units of some operator, one user 1 wants 4 units of the operator, and so on. And the user 4 might come again, right? So the same user might come again, and the users need not come exactly in the order. So any ID of the user might just come in, right? That also creates a problem if we have array-based implementation, where user ID is going to be used as an index, right? So you need to find out the max and then assign values. Alternatively, we can use some other, for example, list or a queue or a vector, and that will help us. Okay, so that is our input format. How are we going to read that file? If I'm using just scene and like we do from the user input, any suggestions? You understand the problem, right? So I am using scene, which needs to be given as a from the. So when I compile this program, it is going to wait for the user input, right? So it is just waiting. But I have that inside a file. So how should I give that input? Copy paste, right? So that is one way. Any other? What could be happening on hacker rank? Right? So nobody is sitting there as an operator, nobody is sitting there taking your input and giving it to your program, right? Okay, so one way is that we can use fopen file related functions to do that. But another way is what Basu has suggested. We can use some sort of a redirection, and I think Andrea as well as no, I think Aniruddha's suggestion seems to be different. We can use these operations. So I'll just show you how to do that. um, a dot out taking input from call center input. Right? So that less than sign on the command line, you can just read that from that file. So wherever there is C in, that is going to read from that input. Right? And then it has read that input, it found out that there are a number of operators, and then there are different operations that it is performing, and this is the kind of simulation that is being triggered. We'll discuss this simulation in the next class more carefully, but that less than and greater than can be very useful when you have the input inside a file. And if I want the output to go into the file, I can do that too using that greater than. So I want the output here. So it has read the input. Now there is no output that is coming on the screen. And once the prompt comes back, that means that the output has gone to that file, right? So let's cat that file, and it should show exactly the same output, right? So that file now contains the output. So this can be very useful when you run your codes, or you can use fopen, fread, fwrite, etc., fclose. But if you have written the code using C in, C out, you can as well use this input redirection. Okay, sounds good. We'll stop here. I'll wait for any questions. Otherwise, if you have a class or lunch, go ahead. These are G++ commands or Linux commands? These are Linux commands. You can just do it for any file, right? So for example, I can do an ls here. For example, if I do an ls here, right? So these are all our code. So I can do ls redirected to some output file. And that output file now contains whatever was the ls output. Right? And I can also give the input in a similar manner. Okay. Any other concerns? Okay, so if there are no further questions, we'll stop here. See you in the next class.